I want to start off by just showing you some code. I just did a quick Google search. Show me a player controller on GitHub. And I think this was like one of the first or second that popped up. I won't credit it because, I'm basically going to say this is the problem we're going to try to solve today. So this is 186 lines out of this entire class of 367 lines. The update loop, they did a good job. They kind of had a little clean here. We're going to update the camera, update the movement. Why I need to update both of those in a single script is maybe a little bit of coupling. But the update movement for a player is this conglomeration of if statements, if nested if. I think I counted there were 22 different if clauses here. And so if you think of the complexity of that, that's 2 to the 22nd possible branching if each if was independent. And so what we want to do today is we want to look at ways of how to make this better. And so we're going to work on a couple examples here that are even a little easier to understand, but this is still rather complicated. So here's an algorithm to move a tank in a game. And again, we have nested if statements of branching here that's pretty bad code. So we're going to try to take this tank movement, which is going to turn it, move it to position, and then fire it into something very simple, right? Turn, wait a little bit, move forward, and commence firing. The way to do this is going to be using a concept of coroutines, in particular Unity coroutines. And again, the problem we're trying to deal with is simplifying code. So we have state machines. We have a lot of times you'll have this checking for time all the time. Do I want to kind of wait for something? So here's a delayed destroy. I'm going to keep looking at my elapsed time. When it gets a certain threshold, then I'll destroy the game object. Otherwise, I'm going to just move my object. And so we have, two totally different things going on here from a concept of cohesion. I have one that's trying to delete this projectile after a certain amount of time, and the other that's just moving it forward. Another common case is here's a simple, I just need an FPS counter. So my GUI has an FPS, and I'm going to basically update it every so often and display that in the GUI. And so this code actually is taking up more space than the actual work I want to do of adjusting the input and adjusting the player. Okay, so what is a coroutine? Well, if you go to Wikipedia or Wiktionary, you can get several different definitions here. So this one is coroutines are computer program components that generalize subroutines. Those not familiar with Fortran, subroutine we would call a method in C++ or C#. Okay, for non-preemptive multitasking by allowing execution to be suspended and resumed. Okay, so now that we know what a coroutine is, okay, let's look at a different definition. Coroutines are very similar to threads. However, coroutines are cooperatively multitask, whereas threads are typically preemptively multitask. This means that coroutines provide concurrency, but not parallelism. Okay, so we have concurrency, but not parallelism. So now we understand, right? Okay, third time here, a piece of code that performs a task and that can be passed new input and return output more than once. Okay, so maybe that new input you might think more of as state rather than input, but we're starting to get there. I think it's going to be best to show this with examples. But there's also, this is kind of, I think, from the Wiktionary, hyponym, which is basically a more specific meaning. So coroutines are going to be a superset of subroutines, okay, which you typically, this is your method. It's going to take input once, it's going to execute, it's going to output. Okay, now it could output nothing, it could input nothing, but your concept of a method, you execute it, it runs, it's over. Versus a generator where you execute it and it continually provides output. So this is our enumerator, right, or iterator in Java. So in a for each statement, it's going to basically yield a new result every time we kind of ask for that iterator to move forward. So coroutines are even a more generalization of these two. So from a Unity standpoint, they're actually fairly easy to understand. Think of it as a branching of a new update loop, okay? So it is basically going to be called or resumed, if you will, each frame until it's done. So, I kind of said it's called once, much like iterators are called once, but the fact that we resume and the state changes means that I have new input every time. So, okay, or you're within that for each loop, it's called every time. All right, so examples of what we can do with these, is again, complete a small subtask, okay? Or, it might be a task that's going to run for infinity. So I have a while true here. Do something, every 5 seconds, take a pulse of the game, or every 1/10 of a second, redo my pathfinding, check my AI behavior. So it's great for delays. It's great for state machines. And it helps you clean up your code quite a bit, okay? And so here's an example of the previous two simple ones. So this one is the delay destroyed. So update, all I have to do in update is move so think of this as for a bullet, right? I'm gonna move the bullet, and if it doesn't hit anything after X amount of time, I'm just gonna destroy it, okay? Or actually, I'll destroy it regardless after X amount of time. So I am going to, in my update, just move it forward in the current direction, current speed, multiplied by delta time. But as soon as I kind of launch the bullet or fire the bullet, missile, whatever it is, I'm just going to say, hey, you know what? Let's call this coroutine delay destroy with a timeout, okay? And it's really just going to sit there. It's going to wait for seconds. As soon as those seconds are over, it's going to destroy a game object. So this is going to use the enumerator type. So start with coroutine requires an enumerator, and under the hood, it will do all this magic for you. And wait for seconds is again a different coroutine. So this really is saying, here's a new coroutine. Do this one for timeout. And then once you're done, continue execution on this one and delete this game object. So now I have, two one-line methods. Update's real easy to understand. I've kind of gotten rid of this delay destroy out of there. And even my delay destroy is only 2 lines. For the frame FPS counter, frames per second counter, we had this, again, time plus delta time, check the time. If it's after an interval, update the FPS, set the timer back to 0, and then do what I really want to do. So again, my update, maybe I need to increment a counter for my frame number, and I'll do what I really need to do, okay? And then in awake, I'm basically going to have this while true, this infinite loop. And there are ways to stop this without having to put a Boolean or some other kind of weird logic in here. But again, I'm going to wait for this case a half a second. Good programming would make this constant into some configurable parameter, or at least a constant somewhere. And then I'm going to divide the number of frames by that time interval, and I'll reset my frame number. So, this is running in the background. Again, it's cooperative, so it's not running in the background on a new thread. What happens is Unity will basically treat this like another sub update. So it's going to call like an update every frame on this as it's doing these others, okay? And so that's kind of the concept of coroutines. There really isn't a whole lot to know. You have this start coroutine. Oops, sorry. You have this start coroutine call that you can use, and it just needs to have an IEnumerator as a return type. Okay, and you can have arguments. You can have many arguments. You don't have to have one. You could have no arguments. And you're going to use that yield keyword in C# as you would with any IEnumerator to have it progress. Okay. So here's an example we'll work through, and this is kind of a nice example from GameDevBeginner.com. So we're going to have a tank that's going to move a tank into position and fire it. So several things we want to have happen. One is we need to rotate the tank to face the target. We're going to move the tank forward until it's close enough that it can actually fire upon our target. In our case, I think we'll then wait, they have to load the bullet or whatever. And then we will fire a bullet, I guess, right? Whatever tanks fire. So I'm going to say there's 5 states here, even though there's only 3 bullets. So here is code that we would typically do before coroutines, right? And maybe we would structure it a little better, but again, this isn't one monolithic method. They're calling a routine called tank method or turn tank. They're calling a method called move to position. They're calling a method fire tank. And turn tank will adjust these booleans, I guess, whether it's facing the right way or angle is wrong, I guess. Actually, if angle is correct, then yeah. So maybe not the best code here, but we have this concept of, I really have different states, okay? I have turning, I have moving. In this case, I have a time delay over here, and then I have firing the tank. And our 5th state is actually, if all of these if statements turn out to be false, right? In which case, move tank is a no-op. So that's our fifth state. Okay, so using coroutines. So again, update will start a coroutine. So we'll do move tank, and now we have a much simpler state machine. So anytime I want to fire, update will say, okay, let's fire off this move tank coroutine, and then it'll go till completion, and then once it's done, it'll go back to idle. And if I ever want to move and fire again, it'll fork off another instance of the coroutine. Okay. So I wanted to keep their code pretty much the same. So again, we have an IEnumerator here. While facing the wrong way, we're going to turn the tank. Yield return null. And so this while loop will go until turn tank changes this Boolean variable. Again, not the best code, but I wanted to follow their example, so you can follow it from this web page as well. So maybe this should return a Boolean that could do that. And then once it's facing the right way, we're just going to move to position, end the frame, move, end the frame, move, end the frame. So these yield return null are kind of one of the workhorses. I've showed you the yield return wait for seconds, which we're going to use down here to have a little delay before we fire. Yeah, I guess my example, I put the delay after the turning. I meant to have it before the fire there. And so what it's basically saying is, hey, we're done calculating what we need to do for this frame. This null, yield return null. This one says, hey, we're done calculating what we need to do for a fixed amount of time. And there's wait for end of frame. There's several wait for classes in the Unity framework there. Okay, but here you can see if this is called, we're going to go through 3 states. So it's not only a state machine, but it's actually a specific execution through states. So turn the tanks, move to positions, wait, fire. So it's going to do those 4 in sequence. So you can think of coroutines as nice little state machines. And again, these could be a hierarchy. So within turn, I might have fire off a couple more coroutines. And so, you know, if you want to kind of sketch your state transition diagram for an algorithm here on the right, I've kind of had this as a little exercise that you can work on. So this one, I'm going to slightly change. I'm going to say I'm going to have 2 distances. So I'm going to have my maximum distance I can start firing. You know, so once that's there and my rotation is complete, I'm going to start firing. The other thing here is I'm just going to start my rotation. You know, I'll stay in place for a little bit, but I'm not going to wait until I'm entirely rotated before I start moving the tank in the direction, right? Rotating my turret and moving my tank now are 2 disjoint operations. So I want to rotate as I try to move the tank towards the target. I guess you could split this out into move, rotate turret, rotate tank, move tank, if you want to make it even more complex, right? And so I'm going to keep moving and I'm going to keep firing once I've kind of reached this distance close enough to start firing. I'm going to move towards it, fire, move towards it, fire, move towards it, fire. When I reach kind of a minimum distance, I will stop, but I'll keep firing. And then, you know, some point in time, I probably need to stop firing if our bullets are having any kind of impact. Little pun there. So, you know, this is even more complicated than the previous one, right? And so I'll leave this as an exercise that you can do, where you try to figure out the state transition diagram of this and what the coroutines would be. And again, if I have these little pieces, they're much easier to pull apart and combine. You know, programming 101, 401, whatever you want to do, but good coupling or good cohesion, little coupling. Okay, so a couple more things you need to know about coroutines is, since they do use the update loop, they need a mono behavior. So that's kind of the driving. So I can't call start coroutine unless I have a mono behavior to call it. Now, my personal preference is try to not to use mono behaviors as much as possible. They're a little fat, and I think they get in the way of clean programming a lot. But you don't have to derive your class from mono behavior in order to use a start coroutine. I just need a driver. So you could pass in a dummy mono behavior in the constructor. You could actually create a new mono behavior to use, or you could even use a singleton. So in this case here, I have some local field that's a dummy coroutine handler, and I'm just going to say dummy coroutine handler dot start coroutine. So rather than this dot start coroutine, I'll have dummy coroutine handler dot start coroutine, and I'll pass in my IEnumerator. By the way, I always type IEnumerable and it's IEnumerator, and you'll get those kind of funky errors. So really, that's all I have to talk about on coroutines. Just some more examples here. So here's another slightly different example. In this case, I want a spawn controller that's going to create a stream of game objects every so many seconds, let's say 5. And I'm going to do that, say, for 3 seconds. Sorry, let's create a game object every half a second, and I'll stop that after 3 seconds. So I've spawned 6 enemies, and then I'll wait 10 seconds, and then I'll spawn another 6. And so this will repeat over and over and over, okay? So this last part we can start with, repeat until game is over. That suggests a while game not over, or while true, and we'll kill it when the game is over. This uses a spawner framework that we kind of have implemented. But here we have our start method. We're going to create a new spawner. You can ignore the details here, but it's going to take in a prefab. And then I'm just going to fire off this coroutine, spawn control with delay. And then just going to say while true, I'm going to fire off another coroutine. And this one's going to say spawn control. And spawn control is going to say while true, asynchronously spawn a prefab, okay, at a location. So this prefab is included in this spawner. I'll wait for the trickle between spawns, spawn another one. So this will constantly kind of spawn at this time interval of trickle between, okay? And then, so this is going concurrently with what's happening in here now, since I spawned this off. So now I'm going to wait for X amount of time, and I will stop this spawn control. So that was part of the reason I wanted to do it this way, because I wanted to show you the stop coroutine. So I will stop the trickle, and then I will wait for delay between spawn restarts, and I will start it back up again. Okay, so this is kind of using the start stop. You could put a while time interval here if you wanted to and not have the stop, and it would just fall through. It's just as easy, I think, to use these start and stops. So that's one way of implementing that spawner example. Yeah, and again, don't worry about these details here. Really, the entire coroutine was these wait for seconds and spawning off a new, or not spawning, starting a new coroutine. Okay, and so the logic, that's going to fire off this one's going to fire off that one, and it kind of works. So you can think of using a coroutine anytime you find yourself keeping track of time. And again, I could have time interval like we had for the FPS counter here, rather than while true. I know it's kind of hard. You've been taught avoid infinite loops your entire career, so seeing while true is a little bit disconcerting. But they're stopped externally rather than internally, I guess. Okay, well, let's try to make it a little more complicated, and this will be left as an exercise. So now we want to use the spawn method to spawn new enemies from a portal. So we'll add a portal. So this is kind of coming out of Plant versus Zombies, one of the game modes where you need to destroy the portal in order to survive, right? But it's going to have these waves. So I'm going to also have it kind of have a consistent stream of one enemy every 5 seconds, and then we'll do a wave every 30 seconds where I'll have some number of enemies come out. But that number of enemies is going to increase by 5 each wave, okay? So, if you don't get to this portal and destroy it, then eventually you'll have 2,000 enemies being spawned, and they will overwhelm you. So again, we'll use a stop coroutine rather than an if statements to, once the portal is destroyed. There's also a stop all coroutines. So that really should be used, stop all coroutines, I guess, if you want, or you can keep track of them. The one point I didn't make here was I kept track of this trickle spawn. Okay, and that's what allowed me to do stop coroutine. So up here, I didn't care. I didn't keep track of spawn control with delay. This one, once the game's over, assuming it would just stop everything. But I could also keep track of it, and if I wanted to do a nice stop, I could stop. Or if I needed to stop for some other reason. You just need to keep track of this coroutine that started, and then you can call stop on it. Okay, some questions that I were asked on this is, what can we return? So we have wait for seconds. We also have null. What is this new wait for seconds? What is being returned? Well, the way to think about this, and could I return something else? Could I return floats? Could I return game objects? The way to think about this is, it's supporting this IEnumerator interface, which is, a non-generic version. So you don't really have anything that's really being returned of use, or you'd have to maybe do some casting. In this case, Unity doesn't care. It's going to totally ignore it. So it's really just a ticking, every frame yields something. And so null or no ops or objects of no consequence really is what the current value, I guess, if you look at the implementation of IEnumerator. We don't really care. We only really care about the move next in the implementation of IEnumerator. So yeah, calling method can't really do anything with it, so you don't really have anything to return. You don't want to return anything, and that kind of answers that. So yeah, I'll leave you kind of with that hook of trying to figure out how would I implement this spawning example where I want to kind of destroy those. And again, the easiest way is sketch out the different states either in a table or in a flow diagram, state transition diagram, trying to figure out what you want, and then maybe implement a little coroutine for each of those. So that is all I have right now, and I thank you.